We're talking about solving quadratic equations by completing the square, and here we have some examples. Remember to start out with our a value has to be 1. So in this case, our a value is 1, and we need to not have a c value. So in order to get rid of that c value, what we're going to do is we subtract the c value from both sides of the equation, and then we are left with x squared plus 6x. Now, in order to get this to be a perfect square, we're going to have to eventually add some c value, so I'm going to leave a space there. We subtracted a -4, and if we add a c value to the left side, we have to add that same c value to the right side. So how do we get the c value? Well, the c value is whatever our b value was, so c is going to be equal to, that equation is going to stay the same, so we're going to take the b value, divide by 2, and square it. Our b value is 6. So here we get 6 divided by 2 is 3, and then 3 squared is equal to 9. So in order to keep this equation balanced, we have to add 9 to both sides. But this 9 here, adding 9 to this side is going to make that a perfect square. So we have our trinomial. That's going to be the perfect square. So the only two numbers that multiply together to get to x squared are going to be x and x. And then remember, this value right here, whatever the value is that's squared, is going to be the value that we substitute in here that's going to allow us to have that perfect square, two binomial perfect square. And then on the right side, -4 plus 9 is 5. So now we can rewrite this. We have a binomial multiplied by itself. So it's going to be x plus 3 squared is equal to 5. We want to work to get x by itself. So first step is we got to get rid of that exponent. So our square and our square root cancel. On the left-hand side, we're left with just that binomial, which is x plus 3. And on the right-hand side, we are left with, anytime we take the square root when we're solving, it's going to be plus or minus the square root of 5. Now we still want to get x by itself, so we subtract 3 from both sides. And our final answer is, and we leave it as an exact answer, is going to be x equals, we still have that -3, then we bring down the plus or minus the square root of 5. And that is our exact answer. We have another example to look at, a little bit more complicated, doing the same process. Our a value we see is 1, and we see we have a -1 as our c value. So in order to get rid of that c value, what we're going to do is we're going to add 1 to both sides. So we can bring down our x squared plus 3x, and now figure out what some c value is that we're going to have to add to that side of the equation. And that is going to be equal to 1, and we're still going to have, whatever that value is that we add here, we're going to have to add it there as well. So our c value that we need to calculate is always going to be the same. We're going to take our b value, we're going to divide it by 2, and we're going to square it. So our b value in this case is 3. Now, I can't divide this and allow me to square it very easily. So I'm just going to leave it as 3 over 2 squared. 3 squared is 9, and 2 squared is 4. So that's what I'm going to add to both sides of the equation. So I'm going to add 9 over 4, and I'm going to add 9 over 4. So now you're like, oh man, there's a fraction in here. That just got complicated. But we got to remember, yes, that is a fraction, but we know what's going to give us that perfect binomial. It's whatever value that we're going to square there. That's going to be what we put in the binomial. So only thing that multiplies together to get us x squared is going to be x times x. We have what we're going to need in order to get into our binomial. It's whatever value we're going to square here. So that's going to be 3 over 2. Now we have a fraction to add. So another way to write 1 in a form that we can add to 9/4 is 4 over 4. 4 divided by 4 is still 1. It's just in a different form. But we had to change that in order to add our fractions because we needed a common denominator. So that becomes 13 over 4 when we add those two together. Now we can rewrite this as our binomial, which is going to be x plus 3 over 2, our binomial squared. The reason we got this far is we want to get rid of that squared term there. So we take the square root of both sides. Our radical cancels our exponent. On the left-hand side, what we end up with is x plus 3 over 2. And on the right-hand side, we took the square root, so we have to have plus or minus. And we can split this radical up as the square root of 13 over the square root of 2, the square root of 4. And we know the square root of 4 is 2. So that's plus or minus the square root of 13 over 2. So all we did was rewrite this radical over here. So it's going to be plus or minus the square root of 13 over 2. Now we're looking for exact answers, so don't overcomplicate this. We have a fraction and we have another fraction. We do not have to get this down to a decimal or one singular fraction. In order to get x by itself here, we subtract 3 over 2 and we subtract 2. Now we cannot, the 3 over 2's on the left side cancel each other out. So we're just left with x. But we cannot combine these. We cannot combine this radical with this fraction. So we just have to leave it as negative 3 over 2 plus or minus the square root of 13 over 2. And that is our exact answer. We can't do any further simplification other than that.